Chapter 3 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This reading by Allison Hester of Athens, Georgia. Curiosities of the Sky by Garrett Serviss. Chapter 3 Stellar Migrations. To the untrained eye, the stars and the planets are not distinguishable. It is customary to call them all alike stars. But since the planets more or less rapidly change their places in the sky, the consequence of their revolution about the sun, while the stars proper seem to remain always in the same relative positions, the latter are spoken of as fixed stars. In the beginnings of astronomy, it was not known that the fixed stars had any motion independent of their apparent annual revolution with the whole sky about the earth as a seeming center. Now, however, we know that the term fixed stars is paradoxical, for there is not a single really fixed object in the whole celestial sphere. The apparent fixity of the positions of the stars is due to their immense distance, combined with the shortness of time during which we are able to observe them. It is like viewing the plume of smoke issuing from a steamer, hull down at sea. If one does not continue to watch it for a long time, it appears to be motionless, although in reality it may be traveling at great speed across the line of sight. Even the planets seem fixed in position if one watches them for a single night only, and the more distant ones do not sensibly change their places, except after many nights of observation. Neptune, for instance, moves but little more than 2 degrees in the course of an entire year, and in a month its change of place is only about 1/3 of the diameter of the full moon. Yet, fixed as they seem, the stars are actually moving with a speed in comparison with which, in some cases, the planets might almost seem to be said to stand fast in their tracks. Jupiter's speed in its orbit is about 8 miles per second. Neptune's is less than 3½ miles, and the Earth's is about 18½ miles. While there are fixed stars which move 200 or 300 miles per second. They do not all, however, move with so great a velocity, for some appear to travel no faster than the planets. But in all cases, notwithstanding their real speed, long continued and exceedingly careful observations are required to demonstrate that they are moving at all. No more overwhelming impression of the frightful depths of space in which the stars are buried can be obtained than by reflecting upon the fact that a star whose actual motion across the line of sight amounts to 200 miles per second does not change its apparent place in the sky in the course of 1,000 years sufficiently to be noticed by the casual observer of the heavens. There is one vast difference between the motions of the stars and those of the planets to which attention should be at once called. The planets, being under the control of a central force emanating from their immediate master, the sun, all move in the same direction and in orbits concentric about the sun. The stars, on the other hand, move in every conceivable direction and have no apparent center of motion, for all efforts to discover such a center have failed. At one time, when theology had finally to accept the facts of science, a grandiose conception arose in some pious minds, according to which the throne of God was situated at the exact center of his creation, and, seated there, he watched the magnificent spectacle of the starry systems obediently revolving around him. Astronomical discoveries and speculations seemed for a time to afford some warrant for this view, which was, moreover, an acceptable substitute for the abandoned geocentric theory in minds that could only conceive of God as a superhuman artificer, constantly admiring his own work. No longer ago than the middle of the 19th century, a German astronomer, Maedler, believed he had actually found the location of the center about which the stellar universe revolved. He placed it in the group of the Pleiades, and upon his authority an extraordinary imaginative picture was sometimes drawn of the star Alcyone, the brightest of all the Pleiades, as the very seat of the Almighty. This idea even seems to gain a kind of traditional support from the mystic significance, without known historical origin, which has for many ages, and among widely separated peoples, been attached to the remarkable group of which Alcyone is the chief. But since Maedler's time it has been demonstrated that the Pleiades cannot be the center of revolution of the universe, and, as already remarked, all attempts to find or fix such a center have proved abortive. Yet so powerful was the hold that the theory took upon the popular imagination that even today some astronomers are often asked if Alcyone is not the probable site of Jerusalem the Golden. If there were a discoverable center of predominant gravitative power to which the motions of all the stars could be referred, those motions would appear less mysterious, and we should then be able to conclude that the universe was, as a whole, a prototype of the subsidiary systems of which it is composed. We should look simply to the law of gravitation for an explanation, and naturally the center would be placed within the opening enclosed by the Milky Way. If it were there, the Milky Way itself should exhibit signs of revolution about it, like a wheel turning upon its hub. No theory of the star motions as a whole could stand which failed to take account of the Milky Way as the basis of all. But the very form of that divided wreath of stars forbids the assumption of its revolution about a center. Even if it could be conceived as a wheel having no material center, it would not have the form which it actually presents. As was shown in Chapter 2, there is abundant evidence of motion in the Milky Way. But it is not motion of the system as a whole, but motion affecting its separate parts. Instead of all moving one way, the galactic stars, as far as their movements can be inferred, are governed by local influences and conditions. They appear to travel crosswise and in contrary directions, and perhaps they eddy around foci where great numbers have assembled, but of a universal revolution involving the entire mass, we have no evidence. Most of our knowledge of star motions, called proper motions, relates to individual stars and to a few groups which happen to be so near that the effects of their movements are measurable. In some cases the motion is so rapid, not in appearance but in reality, that the chief difficulty is to imagine how it can have been imparted, and what will eventually become of the runaways. Without a collision or a series of very close approaches to great gravitational centers, a star traveling through space at the rate of 200 or 300 miles per second could not be arrested or turned into an orbit which would keep it forever flying within the limits of the visible universe. A famous example of these speeding stars is 1830 Groombridge, a star of only the 6th magnitude, and consequently just visible to the naked eye, whose motion across the line of sight is so rapid that it moves upon the face of the sky a distance equal to the apparent diameter of the moon every 280 years. The distance of this star is at least 200 trillion miles, and may be 2 or 3 times greater, so that its actual speed cannot be less than 200, and may be as much as 400 miles per second. It could be turned into a new course by a close approach to a great sun, but it could only be stopped by collision, head on, with a body of enormous mass. Barring such accidents, it must, as far as we can see, keep on until it has traversed our stellar system, whence it may escape and pass out into space beyond, to join, perhaps, one of those other universes of which we have spoken. Arcturus, One of the greatest suns in the universe is also a runaway whose speed of flight has been estimated all the way from 50 to 200 miles per second. Arcturus, we have every reason to believe, possesses hundreds of times the mass of our sun. Think, then, of the prodigious momentum that its motion implies. Sirius moves more moderately, its motion across the line of sight amounting to only 10 miles per second, but it is at the same time approaching the sun at about the same speed, its actual velocity in space being the resultant of the two displacements. What has been said about the motion of Sirius brings us to another aspect of the subject. The fact is that in every case of stellar motion, the displacement that we observe represents only a part of the actual movement of the star concerned. There are stars whose motion carries them straight toward or straight away from the earth, and such stars, of course, show no cross motion. But the vast majority are traveling in paths inclined from a perpendicular to our line of sight. Taken as a whole, the stars may be said to be flying about like the molecules in a mass of gas. The discovery of the radial component in the movements of the stars is due to the spectroscope. If a star is approaching, its spectral lines are shifted toward the violet end of the spectrum by an amount depending upon the velocity of the approach. If it is receding, the lines are correspondingly shifted toward the red end. Spectroscopic observation, then, combined with micrometric measurements of the cross motion, enables us to detect the real movement of the star in space. Sometimes it happens that a star's radial movement is periodically reversed. First it approaches, and then it recedes. This indicates that it is revolving around a nearby companion, which is often invisible, and superposed upon this motion is that of the two stars concerned, which together may be approaching or receding, or traveling across the line of sight. Thus the complications involved in the stellar motions are often exceedingly great and puzzling. Yet another source of complication exists in the movement of our own star, the sun. There is no more difficult problem in astronomy than that of disentangling the effects of the solar motion from those of the motions of the other stars. But the problem, difficult as it is, has been solved, and upon its solution depends our knowledge of the speed and direction of the movement of the solar system through space, for of course the sun carries its planets with it. One element of the solution is found in the fact that, as a result of perspective, the stars toward which we are going appear to move apart toward all points of the compass, while those behind appear to close up together. Then the spectroscopic principle already mentioned is invoked for studying the shift of the lines, which is toward the violet in the stars ahead of us, and toward the red in those that we are leaving behind. Of course, the effects of the independent motions of the stars must be carefully excluded. The result of the studies devoted to this subject is to show that we are traveling at a speed of 12 to 15 miles per second in a northerly direction toward the border of the constellations Hercules and Lyra. A curious fact is that the more recent estimates show that the direction is not very much out of a straight line drawn from the sun to the star Vega, one of the most magnificent suns in the heavens. But it should not be inferred from this that Vega is drawing us on. It is too distant for its gravitation to have such an effect. Many unaccustomed thoughts are suggested by this mighty voyage of the solar system. Whence have we come, and whither do we go? Every year of our lives we advance at least 375 million miles. Since the traditional time of Adam, the sun has led its planets through the wastes of space no less than 225 billion miles, or more than 2,400 times the distance that separates him from the earth. Go back in imagination to the geologic ages and try to comprehend the distance over which the earth has flown. Where was our little planet when it emerged out of the clouds of chaos? Where was the sun when his thunder march began? What strange constellations shone down upon our globe when its masters of life were the monstrous beasts of the age of reptiles? A million years is not much of a span of time in geologic reckoning, yet a million years ago the earth was farther from its present place in space than any of the stars with a measurable parallax are now. It was more than 7 times as far as Sirius, nearly 14 times as far as Alpha Centauri, 3 times as far as Vega, and twice as far as Arcturus. But some geologists demand 200, 300, even 1,000 million years to enable them to account for the evolutionary development of the earth and its inhabitants. In 1,000 million years the earth would have traveled farther from the remotest conceivable depths of the Milky Way. Other curious reflections arise when we think of the form of the earth's track as it follows the lead of the sun in a journey which has neither known beginning nor conceivable end. There are probably many minds which have found a kind of consolation in the thought that every year the globe returns to the same place, on the same side of the sun. This idea may have an occult connection with our traditional regard for anniversaries. When that period of the year returns at which any great event in our lives has occurred, we have the feeling that the earth, in its annual round, has, in a manner, brought us back to the scene of that event. We think of the earth's orbit as a well-worn path which we traverse many times in the course of a lifetime. It seems familiar to us, and we grow to have sort of attachment to it. The sun we are accustomed to regard as a fixed center in space, like the mill or pump around which the harnessed patient mule makes his endless circuits. But the real fact is that the earth never returns to the place in space where it has once quitted. In consequence of the motion of the sun carrying the earth and the other planets along, the track pursued by our globe is a vast spiral in space, continually developing and never returning upon its course. It is probable that the tracks of the sun and the other stars are also irregular and possibly spiral, although, as far as can be at present determined, they appear to be practically straight. Every star, wherever it may be situated, is attracted by its fellow stars from many sides at once, and although the force is minimized by distance, yet in the course of many ages its effects must become manifest. Looked at from another side, is there not something immensely stimulating and pleasing to the imagination in the idea of so stupendous a journey, which makes all of us the greatest of travelers? In the course of a long life a man is transported through space 30,000 million miles. Halley's comet does not travel 1/4 as far in making one of its immense circuits. And there are adventures on this voyage of which we are just beginning to learn to take account. Space is full of strange things, and the earth must encounter some of them as it advances through the unknown. Many singular speculations have been indulged in by astronomers concerning the possible effects upon the earth of the varying state of the space that it traverses. Even the alternation of hot and glacial periods has sometimes been ascribed to this source. When tropical life flourished around the poles, as the remains in the rocks assure us, the needed high temperature may, it has been thought, have been derived from the presence of the earth in a warm region of space. Then, too, there is a certain interest for us in the thought of what our familiar planet has passed through. We cannot but admire it for its long journeying, as we admire the traveler who comes to us from remote and unexplored lands, or as we gaze with a glow of interest upon the first locomotive that has crossed a continent, or a ship that has visited the Arctic or the Antarctic regions. If we may trust the indications of the present course, the earth, piloted by the sun, has come from the Milky Way in the far south, and may eventually rejoin that mighty band of stars in the far north. while the stars in general appear to travel independently of one another, except when they are combined in binary or trinary systems, there are notable exceptions to this rule. In some quarters of the sky we behold veritable migrations of entire groups of stars whose members are too widely separated to show any indications of revolution about a common center of gravity. This leads us back again to the wonderful group of Pleiades. All of the principal stars composing that group are traveling in virtually parallel lines. Whatever force set them going evidently acted upon all alike. This might be explained by the assumption that when the original projective force acted upon them, they were more closely united than they are at present, and that in drifting apart they have not lost the impulse of the primal motion. Or it may be supposed that they are carried along by some current in space, although it would be exceedingly difficult, in the present state of our knowledge, to explain the nature of such a current. Yet the theory of a current has been proposed. As to an attractive center around which they might revolve, none has been found. Another instance of similar star drift is furnished by 5 of the 7 stars constituting the figure of the Great Dipper. In this case, the stars concerned are separated very widely, the 2 extreme ones by not less than 15 degrees, so that the idea of a common motion would never have been suggested by their aspect in the sky. And the case becomes the more remarkable from the fact that among and between them there are other stars, some of the same magnitude, which do not share their motion, but are traveling in other directions. Still other examples of the same phenomenon are found in other parts of the sky. Of course, in the case of compact star clusters, it is assumed that all the members share a like motion of translation through space, and the same is probably true of dense star swarms and star clouds. The whole question of star drift has lately assumed a new phase, in consequence of the investigations of Kapteyn, Dyson, and Eddington on the systematic motions of the stars. This research will, it is hoped, lead to an understanding of the general law governing the movements of the whole body of stars constituting the visible universe. Taking about 1,100 stars whose proper motions have been ascertained with an approach to certainty, and which are distributed in all parts of the sky, it has been shown that there exists an apparent double drift in 2 independent streams, moving in different and nearly opposed directions. The apex of the motion of what is called Stream 1 is situated, according to Professor Kapteyn, in right ascension 85 degrees, declination south 11 degrees, which places it just south of the constellation Orion, while the apex of Stream 2 is in right ascension 260 degrees, declination south 48 degrees, placing it in the constellation Era, south of Scorpio. The 2 apices differ very nearly 180 degrees in right ascension and about 120 degrees in declination. The discovery of these vast star streams, if they really exist, is one of the most extraordinary in modern astronomy. It offers the correlation of stellar movements needed as the basis of a theory of those movements, but it seems far from revealing a physical cause for them. As projected against the celestial sphere, the stars forming the 2 opposite streams appear intermingled, some obeying one tendency and some the other. As Professor Dyson has said, the hypothesis of this double movement is a revolutionary character, and calls for further investigation. Indeed, it seems at first glance not less surprising than would be the observation that in a snowstorm the flakes over our heads were divided into 2 parties and driving across each other's course in nearly opposite directions, as if urged by interpenetrating winds. But whatever explanation may eventually be found for the motions of the stars, The knowledge of the existence of those motions must always afford a new charm to the contemplative observer of the heavens, for they impart a sense of life to the starry system that would otherwise be lacking. A stagnant universe, with every star fixed immovably in its place, would not content the imagination or satisfy our longing for ceaseless activity. The majestic grandeur of the evolutions of the celestial hosts, the inconceivable vastness of the fields of space in which they are executed, the countless numbers, the immeasurable distances, the involved convolutions, the flocking and the scattering, the interpenetrating marches and countermarches, the strange community of impulsion affecting stars that are wide apart in space, and causing them to traverse the general movement about them like aids and dispatch bearers on a battlefield, all these arouse an intensity of interest which is heightened by the mystery behind them. Chapter 4.